But first, I'm going to go through some slides about our community that we welcome you to. Data Science DC is one of the groups under Data Community DC, which is a 501c3 with like a bank account and insurance and all these other things that are great and I don't have to handle. There's also Data Viz DC, there's Gen AI, there's Data Engineers, Deep Learning Adventures, there's all kinds of groups you can be involved with, show up in, volunteer at, and our website is dc2.org. Okay. More about Data Community DC. We have a number of board members in the room. Raise your hand if you're a board member. Yay! Okay. Data Science DC organizers. So Janet, Jeff, myself, Ben, Prima. We're at places on the internet, and you can find us there. Thank you so much to our food and space sponsor, Prefect. Prefect is hiring. It's kind of small on the screen, but there's a staff software engineer role, and there's several go-to-market roles. Go to their website, apply, talk to Jeff, talk to the various other Prefect folks in the room who are raising their, there we go, who are raising their hands. They'll be happy to talk to you, or I assume they'll be happy to talk to you.
We're happy.
Okay. Yeah, that's all. No, that's fine. That's all we're asking. Okay. We have a diversity and a code of conduct statements. If something is not comporting with that, come talk to us. Okay, join DC2 on Slack. This DC2 Slack workspace, there's a Data Science DC members channel. Okay, if you want to speak, okay, we have a form now. For a while we were doing this really ad hoc. Now we're doing this really ad hoc plus a form. So you can go here. We will at some point get back to you. Okay, upcoming events. So May 6th, tips for using APIs in data science and AI, and we promise we will get more events scheduled between now and.
I have another event, but not just data science.
Okay, community announcements. So if you have an event to talk about, if you have another group to plug, if you're searching for a job or hiring, say something brief, and people will come up to you afterwards. Jeff.
George Washington has their first annual open source conference, March 24th, 25th. It's right here, so come go check it out. I think it's free, but if you don't show up, they charge you.
That's a good solution.
We're rich.
Okay. One of you. Go for it.
Hey, I'm Chris Dietz. I work for a company called Epsilon. We're a small, veteran-owned government contractor. We are hiring right now for 56 open positions for data engineers, data scientists, data analysts. Minimum requirements, secret, at least a secret clearance. We'd love TSSCI clearances. And if you're interested, go to epsilon-inc.com. Go to our career site, and any of the positions in Falls Church, just apply to one of those, and we'll put you in the right spot. Thanks.
Hi, I'm working with Arlington Tech, which is a high school group, and we just kicked off our mentorship program, which is really great. But one of the things that came out while we were there was the girls' robotics team doesn't have any female coders or presence, and so I'm looking for some female coders who would like to help help the robotics team, but specifically be a role model for the girls. So if you have any interest or want to hear more, just email me at janet@dc2.org.
Okay, hello, I'm Stephen Ho. I'm looking for a job. I'm looking for a data scientist or machine learning engineer position. If you have a job, let me know. Thank you.
We have an event tomorrow on agents. If you're new to agents, deep learning adventures, as on Meetup. There's a cool session at Excella tomorrow at 7 p.m. Join us.
Okay, hi, I'm Rolf from Golf. I'm also looking for work. I have 20 years of app and game development experience. Recently graduated from a data science retraining.
Repeat here. Civic Tech DC also has a meetup here tomorrow night. If you are into, it's a project night meetup, so check it out. Just like Google that and get the meetup and sign up.
What's the food?
There'll be, oh, it's gonna be in Mexican tomorrow.
Code With Me is doing an algorithms meetup, the final in our series. We'll have Thai food and and it's at AWS Skills Center in Kansas City.
Anyone else? Okay.
Hi, I'm Chase. I'm also looking for work. I come from a couple of different backgrounds of data science and data analytics. I've been doing retail analytics for close to 15 years now, but now pivoting to want to look into computer vision for deep sea hydrographic survey. So mapping the ocean floor using computer vision. That's kind of what I'm looking to get into, but also just looking for work in the meantime.
Hello everyone, my name is Jeffrey. I'm also looking for work. I have a pretty strong data science background. I completed my undergrad at in computer science about a year ago, and I have over a year of internship experience doing data science work in the financial services. So if anything comes to mind with any opportunities for entry-level work, don't hesitate to see me after this. Thank you.
Two announcements. Civic Tech DC is also doing an open data event, and we're looking for speakers. So if you use open data, we would love to have you speak at an event. It'll be a March 20-something Wednesday. So yeah, let me know. Also, there's a group of us who are thinking of putting together a queer plus technology thing for World Pride in like May, June. So if that sounds interesting to you, let me know. And I'll be in the Slack if any of you.
Hello, my name is Shazza Braza. I'm from Detroit, and I drove all the way out here for this event. I saw it I guess I'm going to repeat the same thing as I believe 5 other people said, that I'm also looking for a job here in DC, as I love this city. I am going to graduate in May with 3 degrees in math, psychology, and biomedical physics. I do research in nuclear physics, game theory, and I'm right now doing dating science, so dating. So if anyone has any questions about that, I don't look like the one that should be advocating it, but I have done research in it, so nothing more nerdy than actually studying dating than actually doing it. So by all means, if you want to come by and just talk about dating and not about hiring me, by all means you can do that. If you would like to hire me, please do. Thank you.
Thank you. I think there's somebody.
My name is David. I come from a health and tech background. I'm looking for an account management position.
Okay. Anybody else? Any other events? Okay. Oh, Will.
Yep. Hey, so next week on the 18th, Tuesday the 18th, we're having a data visualization meetup over in Arlington. That's going to be on narratives. And then the week after that, we have a data engineering meetup that's going to be right here in this room again.
Oh, and isn't there I'm plugging something else's event, isn't there a lightning talk people can volunteer for data engineers, DC, maybe?
Yes, that's the lightning talk
Oh,
event.
that's lightning talk. Okay, cool. Okay. Are you guys still taking applicants?
Yes.
Okay, awesome. Talk to Will. Okay. Anybody else? 1, 2. Okay.
Hi guys. So I'm Bhumika, sorry. I'm a master's student in George Washington University, and I'll be graduating in May. I'm doing my master's in data science. Are you guys also looking for jobs? I'm going to speak on behalf of all of us. So all of us are here looking for jobs soon in the field of data science, data analytics. So please help us out.
Okay. I think that's it. So thank you for attending. Thank you for being part of our community, and we're so glad you were here tonight. And now, what you actually came for. Pri Oberoi.
Drink it anyway.
Yeah, you're good.
Hello, everybody.
everybody.
Hello.
I am super excited to be here. I actually haven't done Data DC talk in a long time. It's been a while, and this actually feels a little like returning to, I don't know, things that feel good. So I'm happy to be here. I'm Pri Oberoi. Let's see how this works. Okay, can someone tell me if the slide changes?
Yeah.
Oh, cool. That's a great UI. Okay. We will figure this out together. Okay. Maybe once I use it once, it'll like.
There you go.
Yes.
There we go.
Okay. All right. Okay. So I'm Pri. I use she/they pronouns. I am not yet actually, but as of next week, I'll be starting at Atlassian as a principal data scientist. If you know anything of Atlassian, I'd love to hear from you. I'm going to be going to the thing after this. And prior to that, I was at Axios HQ, which was basically building like a B2B product for internal business comms, like your all hands newsletters and stuff. The reason I share that is because that's kind of where I stumbled into this rabbit hole. I was like, oh, so now that LLMs have exploded and now like fine tuning and doing the stuff that we were doing before doesn't work in the same way, and it's not quick enough. What happened was there was a ton of LLM features, like just text generation everywhere, all over the platform, because like everyone could just put in a prompt. And what ended up happening was our users never used it. Because there wasn't, like the output from the LLM was not nearly contextual enough, like it wasn't at all specific. And so at the time I started being like, hold up, there has to be a really concise way that we can provide the right context for the LLM, like even at inference point, if not during fine tuning. And I was like, I discovered something, and then I like Googled around a bunch more, and I was like, this is a field called ontology, which I'm gonna share my slides on GitHub. I have sources at the end. Some of this was like looking at other people's published content. A lot of it was actually in conversation, like on LinkedIn and things like that. Like it feels like a very emerging field, so that's kind of exciting. So I'm going to talk about like what, semantic AI is kind of the reason I ended up going down this rabbit hole, because I was like, this LLM needs to perform better and be like more grounded. What that semantic layer looked like. I'm going to talk through like broad use cases, and then like what it would look like to build something for one of those use cases, and then okay. All right. So semantic AI, right? This is the idea that like I'm going to be talking specific to LLMs, but it's like combining LLMs and some sort of like structured knowledge model. So I know there's a lot of like, ooh, AGI, right? And like the idea of AGI is like mimicking human cognition. And the reason I prefer this approach to like building semantic AI is because it ends up being like smart, context aware, and it's leveraging knowledge from our data. It still requires us to curate good quality data, and that never went away, but I think some people thought it did. So ontologies are one of those kind of knowledge frameworks. And so ontologies, there's a few different things that can comprise an ontology, but it's basically like, it's organizing knowledge. So it's like, you have your concepts, you have your connections and like rules, and then that makes your data just like a bit more meaningful and like something you can work with, something you can take action on. So and then LLMs on their own. I'm assuming a lot of folks are familiar with this, but it's definitely worth saying, right? Like LLMs hallucinate, they make things up. It's like directly indexed to the quality of the data you feed in, right? It's like, it's not gonna scale up. The more, you can't continue to stuff in really long prompt inputs and like provide more context, because it starts ignoring it at some point and it just doesn't scale. So an ontology is a way of kind of like making sure that output is much more grounded, right? It's less likely to hallucinate. It's more accurate, like since the right context has been provided. And also, my favorite, it's a little bit more explainable, right? Because like it's still an LLM, and but what this does is the decisions or the outputs from the LLM are just the slightest bit more transparent and explainable, especially if you end up surfacing some of that context to the user. Like you're indicating through the UX in some way, this is the context I'm using about you. And the reason that's even more powerful is because it gives your users like a better mental model of what you expect, and then they can use the tool better. I will say I was like struggling in like the definitions and like the area of study here because there's a lot of overlap with other things. So MDM, right, like master data management. The way I kind of separate that out is like that is organizing like the core business data. And it's like the idea is it's accessible to systems, right? It's not as accessible to people. And so like an MDM kind of system would ensure that all of the customer data is correct or consistent. And then an ontology engineering kind of approach would have us define what who that customer is and what role they play in our system. Like that's the kind of the distinction between the two. It also seems a little metrics layers, right? Like where you have like kind of pre-computed metrics like that pull from a bunch of your different data sources. That is I think with that's kind of separate mostly because the overlap is if you're working with ontologies, you can probably produce better metrics, but that's like a different setup. I'm gonna pause before I jump into like what exactly the semantic layer can comprise of. And if you have questions, just pop your hand up. Okay. Thanks, Will. All right. So I'm in my head. I always call this is like the sense-making layer, the semantic layer, right? And it can it's basically a standard framework. It defines relationships between content and like enriches content with metadata. And it's like this process of designing, developing, producing these knowledge graphs in the form of concepts, relationships, and rules. So like an ontology, for example, is like a data model that describes some knowledge domain. And it's typically like within an org or within a subject area, like medicine, like a field of medicine. And it provides context for how like the bits of the data are connected. So this is sounding like a knowledge graph. And that's like ontologies are often used to kind of define the model used by knowledge graphs. So they are very, very hand in hand. And it's like that makes a lot of sense. Right? Knowledge graphs are like a great way to just capture like the real world things and then what are their connections, which is exactly what we're trying to do here. Ontologies are defined by like entity type. So like this is an example, like if you had a customer support kind of use case, these would be the entities, like a user. You can have different applications, like different products your users interact with, different features, and then your customer support ticket. And then they might have properties, so your user might have some configurations for the platform when they're interacting with it. You might know something about their usage history and know if they're a fairly new onboarding user or a power user or whatever. You know something about, you have properties about the application itself, the features, and then the ticket of the bug ticket or whatever. And then you also have the relationships, right? So like here is like a user is using the app, or that app has this set of features, and the customer support ticket is related to a particular app, was submitted by a particular feature or user. So you can see how this kind of example I used here, there's kind of levels of ontology. So the topmost level of the ontology is kind of the most abstract, and it's also the most reusable. So I included a link at the end of this, but like there's a really nice resource for just like this top level ontology for different domains, and it's available for free. I think that's like it's just a great place to start. But like where I actually built from was the bottom. And there are a lot of reasons for that, but one, like this is where you actually start to be like, I might have some impact on this product or on the user's journey, and then I might be able to show with some metrics that we made an impact. So a taxonomy is more of like a hierarchical filing system, right? So it doesn't have those same relationships. It's a subclass, superclass kind of thing. Here, like if you had if you had a customer support taxonomy, and like a semantic layer can have both a knowledge graph and a taxonomy. This is like a breakdown of what it would look like if you went into, all right, tickets can be classified into account management, and within that, like login issues or whatever. I'll talk through what it would look like to build one of these from scratch. And then these are really interesting components to me as well. So a thesaurus, a glossary, controlled vocabulary. There was a few other terms I saw for like this sort of thing, but they seem to break down into two kind of broad categories. One is like a real world description of the thing, like this is what a bug, this is how you're going to define a bug, or this is how this feature works, and using kind of the most appropriate language, like the language you want everyone to be using, and probably the language you want your customers to be using. And then there's also like a kind of a controlled vocabulary where it's a standard term so that you can use something consistently. And using, like, it is incredibly important in this process. And it was interesting to see how difficult this was when I was applying this. Reusing like the terms and definitions from existing ontologies, or from what your database and data files might already look like, reusing as much of that language as possible, actually it promotes like a lot more interoperability, so you can use that data. Hi.
Is this kind of thesaurus generated by a human or automatic?
It's like for the thesaurus and the controlled vocabularies, there might be some component where you begin to find a somewhat automated way to expand it or maintain it, but subject matter experts or folks that are familiar with the process, like this is where the really good quality data should live. Yeah.
What about the capacity for the end user to manage their own set of technologies, particularly around nascent ideas?
Can you say more?
New ideas. So if you get stuff that isn't in the database,
yeah,
but it's something you want to track, you probably want to have the capacity to add that by yourself.
Yep.
How you want to manage that in a global sense becomes a sticky problem. Sometimes that stuff is really good and sometimes it's really nonsense.
Yeah.
But,
yeah.
I built a system where the user can put that in.
Yeah.
And it does affect but not overwhelm the universal system.
Yeah.
And can be picked up by other people.
And then perhaps it being picked up by other people.
Yeah, I mean, the theory is that if it gets picked up enough, it becomes a significant part of the system.
Yeah.
And if it doesn't, it'll actually get flushed in my system.
Yeah, that makes a ton of sense. So this like dynamic living system, this is a big part of like having an ontology or a taxonomy or any of they need to be constantly updated. There need to be metrics in place so you can tell when things aren't being updated or are going off filter. I'm gonna say data flywheel, but data flywheels are something I have been talking a lot about at work, and this was one of the first few areas I was like, this is how you make it so your data gets more and more valuable over time. Like I see it immediately.
Does the term synset kind of map to thesaurus, or does anyone use the term synset, S-Y-N-S-E-T?
Synset?
Synonyms. Like things that are semantically equivalent.
Yeah.
They might, like a user might say something, but actually you know that in your documentation you call it this, and you really got to get to that thing.
Yes, and so you still want to know what the user calls it.
Exactly.
Yes, yeah. Okay, so the last two bits, I'm not going to go into them a lot. I didn't spend too much time thinking about these, but like this idea that there are some restraints. This feels more of a guardrail sort of situation, where it's just making sure that you do not end up updating your taxonomy or your ontology in a way that Like for example, you might say every ticket can only have one customer. Like there can't be multiple people that submitted it. And then you can act, and violations of these constraints can sometimes act as really good indicators that like that something is happening like in your system. These are interesting. It's like logical statements basically, and the idea is that they help you get new knowledge. But really, what the way I interpret is that these logical statements allow you to like create a little bit more metadata. The idea is that it helps with like consistency and coherence. It's like a fundamental rule statement. It can provide something about concepts within the domain. Yeah.
How can you limit something to what they are only authorized to retrieve in this layer? Is it possible to build a rule that they cannot do more than what they can do?
They being end users?
Yeah.
I mean, it is entirely possible to have this layer be only Oh, you're saying when they're accessing information from this layer through an LLM?
Yes.
Yeah. So the same controls you would put in place for your databases should be in place here as well. So like Databricks was the last major platform I worked with, and like that would be one where we have our rules on like even for endpoints what users can access and what they can't, and then your knowledge graphs, your taxonomies would fall under the same permissioning. Okay. So the whole idea, right, is like semantic models are letting content flow between like people, machines, and applications. So there's a lot that it could do. The things that I've seen the most people seem to be using this for is automatic content tagging and categorization, like personalizing content, enhancing search, and RAG and recommendations. I actually haven't seen a ton of projects where people are kind of demonstrating the explainability. So if anyone has seen anything like that, I'd love to see it. I also love that it, as a byproduct, it's kind of like you're producing formalized notions for like both machine and human consumption. Yeah, and so the traceable like connections and like a clear data lineage might be what allows for kind of that transparency to come through. But if anyone else has other examples, I would love to hear them. So customer support has like a bunch of potential use cases, right? It could be anything. It could be like you're going to provide context to your customer support agents. You're going to inform what priorities, like what fixes and enhancements should be prioritized. You could advocate for the user, which is something I've noticed a lot of customer support folks, like leaders do. They're advocating for like the user's experience. Or you could be building something to onboard a new engineer. But let's say that we're going to stick with the idea is like this use case is we want to decrease the response time for customer support agents, and like we're going to do some RAG, pull that from past related tickets. It's pretty straightforward. So for like looking at the domain and the scope, we're building around a use case and we want to start really small. I definitely started very small in the project, the ontology layer I created at Axios HQ, and a large part of that was that I needed to show the value of this work really, really early and often. So the fact that I could really early on be like, hey, for the first time ever, here is at scale, like what topics are all of our users sending about? Like that was huge for the product team, even though it wasn't like released into the feature yet. This is also like, so you're looking at the subject matter, the boundaries of what you want to be able to do, and here you want to just like roughly outline the concepts, relationships, the knowledge that we're going to have to model. Enterprise knowledge, is anyone here from enterprise knowledge? Is there local? No?
Oh, there was a hand.
Are you from enterprise?
Responding to the enterprise knowledge.
Okay, you work there?
Oh, I'm sorry, I do it, I don't.
Oh, you do. There's a place here called Enterprise Knowledge that I loved all of their writing about this. Like they're doing a really good job of like kind of creating the research and then creating the field and then doing the work. So I included links to that for anyone that wants to dig in. But this, like, supporting.
That's the shop in Arlington, right?
Yeah.
Okay.
I have to point out that when Pri was at Axios HQ, I believe they were on the 13th floor.
Yeah.
And Enterprise Knowledge was on the 4th floor, 6th floor, something like that. Anyway, same building.
But I didn't know about them then. So like supporting a really specific business need or use case. I don't know if this is how most people's experiences are, if you are like a hands-on data scientist, but I find I have to advocate up for the stuff I want to build, especially if it doesn't have immediately have a flashy marketing bang. And so like advocating up meant like kind of packaging up this work in a way that it would produce these like happy byproducts along the way. So we always want to reuse the terms and the definitions to promote interoperability. So like you're gathering your documents, data files, databases, you want to reach out to your domain experts. We had internal editors, like editors in-house, and I worked very, very closely with them the whole time. The part of why was not just like being like, give me all your documentation, because they did not have a lot of it as documentation. But engaging with them made it so that as I was building out the very first version of the taxonomy of topics, they were able to like just give me some human in the loop like validation along the way. When weird things happen, like one class appeared and then suddenly everything started getting bitten into that class, right? Like I could work with them to do this in like a really domain aware way. And then this is genuinely how I actually feel a little nervous. But I did use an LLM to create the first version of the taxonomy, and it felt irresponsible. And the reason was like we genuinely, they had like 3 or 4 examples of what these topics were, and that was it, and that's all they were using, just like anecdotally. And so I didn't really have anywhere to start. What that looked like, so. Right, you're identifying the hierarchy. The initial rough taxonomy is probably one level, right? Because you're going for one level of granularity at first, and you want to make sure you have as much coverage, which means you have as many examples that don't fall outside of those like larger buckets you're creating. And this last part, use a model to suggest missing additional concepts. Right, LLMs are. This was not an easy process. This was a lot of using an LLM to infer where the buckets might be too big, identifying like what makes sense in this domain, going back to our subject matter experts and being like, hey, this is what this looks like. Also, big deal thing was having a way for the SMEs to look at this output in a visually appealing way. So like not using Excel, like I visualized a ton of this. Yeah.
So in your exploration with other people that were working with this, was this a common technique? And if so, was there any kind of like theory in terms of what would be the best way of going about it? Like I'm imagining an LLM discovering some kind of like latent space and then filling in the properties of where that space could be, or like extrapolating like latent concepts or something.
Yes, and this does seem to be a somewhat well used approach. Some folks have, I included links to this, but there's like methods that allow you to say, okay, like if you are going to have a few humans in the loop, you might use like a quick statistical test to like when there is disagreement on like a taxonomy. So like there are a few methods that you're going to have to use along the way.
Did you use particular LLMs? I mean, when did you produce this extended content?
When did I do this work?
Yeah.
It was like last summer or last spring.
And do you use particular models, or did you experiment with the output of different models?
Yes. So experimenting with the output of different models was a little hard at first because I didn't know which of them was actually producing a useful taxonomy. So the very first version, I believe it was like GPT-4 at the time. Like I was like, all right, I will use this model. This whole process had to be reproducible, which meant that I couldn't just like write the code and have it run and then produce a taxonomy and then not be able to just run that again. So we set up our amazing MLE set up a system where I could just like swap out different LLMs. So at some point, actually like probably after we got to the point where we had a decent taxonomy, I ran a few more models to see like did anything surprising pop out, but I feel like there would have been like an interesting way to do that up front.
How did you visualize the ontologies?
Oh my gosh, what are they called? So there's a visual where it's from biology. I have a genetics background. It's like a circle and it's like a phylogenetic tree but circular. That was very helpful. So like having interactive data visualizations where you are looking at like this taxonomy had 3 levels. So like you can look at the colors by the highest level or the lowest level. I also really like data visualization, so I'm always looking for a reason to go make a data visual. Yeah.
Did you consider just using bag of words?
Using bag of words for creating the very first version of the taxonomy.
Using it, period.
Yeah. The other thing I did consider using was, and I did some initial work with, was like looking at some unsupervised methods, and like using DCA to like at least determine like what we're working with, and they were why and mostly actually the reason I kept using the LLM was because it was so quick to iterate, so quick to iterate. Because I was like, this doesn't work, and then I'd run off in another direction, and like then I get feedback, and at some point I was like, oh, this is easier. So it was lazy.
Question: you mentioned some statistical methods, like if there's like difference of opinion about the ontology.
Yeah.
What were some of the methods that you used?
We actually did not have any disagreement. I didn't have to worry about that because I only had one expert helping me, and basically whatever she said I did. But I included a link to it because there was a really good research paper where they talk about that methodology, and I was like, that's a smart way to do it. Okay. So this is actually I've included some things here. This taxonomy builder thing. They also use this. Like this is how people usually describe using this method. It's like you take text summarization, you do some information extraction, you reduce the search space, right? You're using an LLM to perform some contextualized clustering, which and you're taking the remaining concepts to like yield some candidate nodes, and then you have a user review it. The only like thing I might add here is I did find that since I was interacting with LLM, at some point the taxonomy itself had to get loaded into, like I had to use components of the taxonomy so that the input to the LLM was like aware of the breadth of the taxonomy when placing something in some subnode. And that seemed like a cool tool, Party Semantic Suite. And then that down there is the link to the industry-specific taxonomies and ontologies that you can just use. So organizing the taxonomy, like the hierarchy, you're doing parent-child relationships. You want to generally have narrower terms. And at some point, this was where I just moved over to a classifier. So at some point when the taxonomy was stable enough, using an LLM to do it was just slow and not as good. And so I just switched over to a classifier when we had some version of the taxonomy that worked. However, getting there, realizing that we had a taxonomy that was good enough was really hard. And that's what this is about. Like actually assessing your content fit was one of the hardest things that I was trying to figure out. So it's like you have to try to have a comprehensive enough taxonomy, which for us meant like the highest level had to be complete. We were like, all right, for some of our high level concepts, like our level 1 topic, if a class gets sorted, if something gets classified into one of those, we're not going to build out the lower levels of the taxonomy yet because we have to make things quicker. Consistency, clarity, accuracy, right? Like you want to see what it means to place something in the wrong grouping. That was necessary like throughout the iterative development. So there were a few metrics that I looked at like, I took a handful of like the really weird examples that I noticed kept coming up, and I would look at when they were when they were put in the wrong grouping. So I set up a few metrics in place with that particular data set to help with this, and then you'd run the same thing on another data set and see if it worked. Property and conciseness. Okay. Taxonomy not including any irrelevant elements, like the conciseness component, not having any irrelevant elements in the taxonomy was also one of the metrics I used to see if like how many times did it spin up something that got used very little by the rest of the system. So that kind of goes back to what he was talking about. Like there's some voting over like this makes more sense once we first pull the data set, but this one doesn't make sense anymore. So it was and the properties you're defining for each of the ontological entities. So far we've been talking about a taxonomy. The other component of what I built was we should be able to identify who's sending to whom on what topics. What topics was the taxonomy, but who's sending in terms of what's their role and who are they sending to? All employees, one department, just the leadership team, and that was actually not data that we had. So identifying what attributes we want to collect about each of those, about the user, about the audience. And there are a few standard ontology languages out there. Translating a conceptual ontology into a formal encoding, that part was very easy. Especially once you've like gone ahead and like specified what your classes are going to be in, who are the individuals in it, and the properties and the relations. Yep. So, wow, I feel like I've said refine iteratively a lot of times, but that is what we did. It was a lot of looking at the gaps, the inconsistencies. The LLM was usually, like anytime I used an LLM to search a space to see whether there were improvements or additions that could be made to the taxonomy, just as much as it got something right, it went off the rails, and so it would have been really hard. Yeah, Will?
Could you say a little bit more about ontology requirements and how would you make requirements for building on an ontology?
Yes. Actually, I think I have that coming up.
Oh, perfect.
This is what I was saying before, like this is a dynamic evolving system. Talked about this. Once you do populate the ontology, testing to see whether all of the individuals have been like sorted in a logically consistent manner. These are helpful reasoners that can look at like logical consistency and talk to your experts. Yep, and then this repeating evaluations over and over, task-specific evaluations. Okay, so the human readable descriptions, like annotating ontologies, human readable descriptions, documenting the competency and like limitations of it. DPROD is a really clear schema for describing like the data product as a whole. It also makes it like, so we're actually treating data products with the same amount of accountability as traditional products, which I think is necessary. All right, and then just to close out, like what I would love everyone to walk away with this from is like, so KPIs are really hard to measure the impact of adding a semantic layer, right? It's increased efficiency, reduced cognitive load, improved cohesion across an enterprise. Those are really hard things to measure. But measuring specific metrics for a particular use case can be a great way to advocate up. And the other thing is, I call this work a central knowledge repository a lot. And I weirdly came across that term, but this like advocating up for like describing what this is, It was helpful to describe it that way. All right. Okay. Thank you.
What is the actual tech stack you're using to implement a lot of this? So like, I've gone for like a couple of years and I've figured there's not that many great tools in this space. It's like pretty theoretical, so I build a lot of my own tooling, but I was just wondering what you've done.
That was very much my experience as well. A lot of this was building my own tooling, and I mean, as I was researching this, I feel like there are a few more, it does seem like there are more companies coming out that are trying to build tooling for this, but it is a pretty new space, it seems.
Yeah.
Someone else have their hand up?
Yeah. How did you convince people, the users of using a knowledge graph over just like a standard relational database with with associated data model? Because that's like the analogous thing, right? So you did an ontology, the analogous thing in a relational database is a data model.
Yeah. The only reason I think that, and I didn't get a lot of pushback on this, but it was because when I turned this into a knowledge graph and I was having an LLM traverse over the knowledge graph when it was doing inference, I kind of set up the system that way. So I don't think I ever got pushback on that. What kind of pushback do you get back? Do you, like, why is there a reticence to use a knowledge graph?
Yeah, it's not like you said, it's not, and I believe it in, it's pretty sophisticated, but like, okay, I mean, you can argue that you can do a lot of this with just a database.
That's true.
A lot of it, not all of it, a lot of it, but not the fancy inferencing and like very tight formal checking.
Yeah, that is true. It also is much easier to look at, and there is something to be said for that. Yes.
One thing I've always had a feeling about with regard to ontologies is that you go to a lot of work to develop them, and then they can have a static quality unless you're constantly updating them. I mean, even if it's something as simple as a business's various divisions, product divisions, etc., that the dynamic organization that really comprises your knowledge, your domain experts, is such that they end up spending more time dragging the ontology along to stay, concurrent with the changes, that it just becomes an added burden, frankly.
Yeah.
And so I'm wondering if that was an atypical experience.
Though we put a workflow in place that would allow the ontology, actually specifically the taxonomy, to change over time, and allow updates, I think, nodes or branches to get added. And then this was we at some point created like a visual tool for our humans in the loop and added like an embedding space.
Sounds familiar.
So it was like 2D scatter plots where they're looking at like, okay, this is like in the last week or so, this is all of the new sends that have gone out, and that's where we mine our like topics for the taxonomy. And these are all of the ones that got put into that got put into known topics. And then these are like the new topics that came up. And so they were really just like looking at a dashboard once in a while, and like they'd be like, oh, this looks wrong, and then they'd flag it. So having a UI for that made it much more useful, and then they were validating the updates rather than making them.
And sorry, if I may ask a second one. From the customer service point of view, that person's point of view, how did this improve their life? Did they have a new user interface, or how did that play out?
Yeah. So the thing I was building at Axios HQ was separate from a customer support RAG thing. I just felt weird using their data system for them anymore. However, I talked to customers, like our head customer support person at Axios HQ. I reached out to a bunch of people who are contacts of mine that do customer support engineering, and this sort of it doesn't seem like something like this has been actually executed well so far based off what's on the market. And when I was thinking through this problem and like being like, how would we actually solve it? Part of what I imagine would happen is you would have like whatever chat interface where you're interacting with your customer, tickets that might be related with like components pulled out where someone could validate easily, like, hey, that makes sense, or hey, that does, like that was helpful, this was not helpful.
So they score
Very
them?
brag-like, huh?
Yeah. Yeah. Okay, thank you.
Okay, so I always have to ask about this. I wrote down that you had a classification problem when you were creating your knowledge graph. Was this like its own machine learning problem where you had to like create a classifier and like evaluate the F1 score? And was that like an independent model, or was it the LLM itself?
That was at some point, like at first I was using the LLM,
Yeah.
and then that doesn't scale, so then I moved over to a classifier model. That performed
interesting.
really well because I was training it on what I had already like kind of classified with the LLM and validated.
Okay.
Yeah.
So kind of along the lines of visualizing the data, like were you, like the data set that you're using to build this knowledge graph, was it a large data set? And if so, like, were there any strategies that you used to like prevent, like, you know, to not have to see like hairballs? Because like when you're working with a large data set.
What helped me scope down the data set and what scoped this down wasn't actually, like I didn't get to that problem first. Because I was working with our humans, when they loved it when I called them that. We ended up selecting a couple of our really large companies because they were like, we're more familiar with this. And I was like, that's perfect, that's great. So like that just like decreases my problem set, and then they were able to like iterate with me faster.
That makes sense, yeah.
Yeah.
And this may piggyback on one of the previous questions. Have you used GraphRag at all with?
I have not. Have you?
Yeah.
Yeah.
So, and I think it answers one of the questions, which is why would you use a graph database rather than relational?
Yeah.
And it's a couple of things. One, it's the iterative data model. Like the schema can be changed, and it's far more flexible than just a relational. Like if you change something in a relational that you didn't originally create the data model to answer, it's gonna break. Whereas graph databases eat those for breakfasts. and the explainability is big. Neo4j comes with data science algorithms in it and a visualization application within it as well. And for my customers, the governance piece, like you could lock, like LLMs are kind of a black box right now, but if you have the embeddings within a graph, you could lock down some of the answers, and then you can see why it gave you the answer. So that's why I'm really pushing GraphRag.
Nice. What's your name?
Oh, Jemakai.
Alright, we should all talk.
Yes. So I'm personally very convinced on like the value of ontologies, the values of good documentation, but as you've acknowledged, there are costs. For non-specific use cases like this, what would you say is a good sort of heuristic for thinking about when we should put in the effort to build these? Like what's the sort of read to write ratio that we should be looking for if we're doing, say, like ontologies for internal documentation within a company?
So are you asking what level, like what the ideal level to begin your ontology at is?
So more of sort of my like strategy, like beginning to build an ontology. Say you're an organization, and I've been involved with a number of projects around like data catalogs, business catalogs, really documentation and organization efforts that involve some aspects of portions of ontologies. I've seen some of those be very successful, many of them be less successful. I think like Anne was saying, a lot of work goes into building these ontologies and then they get dragged around and don't necessarily deliver the value that people want. So do you have any advice around thinking about when we should build an ontology, when we shouldn't?
I will gladly say I don't know the answer because I never got, I actually really worried about the point at which our taxonomy and our ontology grew bigger than it was. Because by the time I was at, like, we were serving a very particular use case, and like the taxonomy was really well defined, but it was a set of topics, and that will grow over time. And then we didn't build any higher level systems. So like I wonder about it at night. I think about how it's doing. Yes.
Identifying synonyms.
Yes.
How do you do it?
Well, so the synonyms, right? Because it isn't just like, is it semantically similar? It's kind of like what we were talking about before. Like your users are using this word, but you don't use this word. Like, so we, like in these internal comms, every little article, we call them cards. Nobody else calls them cards, but all of our documentation called it cards. And so the primary way we began to look for those kind of terms that might go into your thesaurus was by looking at the linking between our support requests and our support request, so because users usually use the chat, so the support request text, and then what feature they ended up finally using.
So you don't have any automated methods to do this?
I'm sorry, Rick?
Do you have automated methods to do this? To identify synonyms?
So
It's
we
a
had.
notoriously difficult problem.
Oh, I believe it. So for our very first, like, this was not a continually running system, and I think to be really good, it would have to be a continually running system. We had a job that ran once every 2 weeks while we were building it. While we were like, we're pretty sure that there are still more things that we can add to the source that have not been added yet. But I could imagine building, because we were getting that data specifically from customer support, I feel like there could be a good automated system that could be built into that, but we didn't build it. Yeah.
Okay. I've been working on that problem for over 25 years.
Cool. So like next week.
I solved it 27 years ago.
All right, we should chat. Any other questions? Oh, yes.
Thank you. So when you talk about traversing the ontology, like the LLM traversing ontology, that sounded very interesting because LLM, for people like me, it's just like you type with it. So how does the LLM traverse an ontology? What's that?
One of the main ways we did that was embedding each of the. So there was an embedding of all of the values, like the node for each class or property and whatnot. And we would use the embeddings when we were doing a search to try to find the potential match, and then look at use the traceback of like for example, if it's a taxonomy, use the traceback of, actually let's not use the taxonomy because that wasn't a knowledge graph. It was just a hierarchical list. So for the ontology, use a text description of the traceback during inference. And so if there were like 6 candidates that were found that could be good matches, each candidate would include its traceback of like the ontology of like how it connects back to what the user requested as a text description. Like, so it'll be like this customer ticket issue is related to, and then that, and so there'd be like a weird blob basically describing it, and then that would be part of the ultimate decision about which of the candidates to return to the user.
So that meant that the LLM was able to understand the language of this blob about the ontology without.
Yeah, well, I mean, like the input included like, this is an ontology. The way you read this is that when arrow runs this way and it has a term describing the relationship between the 2 arrows. Like, so there was like a little spiel where it's like, this is how I'm going to represent the ontology, but describe it to the LLM in a way that is like, this is what what this means. And then it was, just a text string that describes like the property, and then the what that property belongs to, and then what the relationship is with the next node. So.
Thank you.
It was weird, that part. I was like, this is what, passing that in as input was definitely, I don't know if other people do it differently.
And did you, for those, that prompt engineering Did you find that the large language models responded better to different phrases? If you said like, this is what an ontology is versus like, this is what you know.
Yeah, definitely. Because it made it, like, when I did use words like ontology, it made it really weirdly scientific and specific, and like it started to go into the wrong domain. Yeah, and like I found that to be true even with the domain I was working in. It was internal comms, right? And like if I tried to use any of our terms, the LLM would not perform as well as if I was like, all right, it's a newsletter, and then.
I'm sorry. One more. I have a question related to him, related to his question about traversing.
Yes.
So my understanding is, did the LLM spit out a text description of the ontology traversal? Is that how you
Yeah. In its output?
Yeah, in its output.
No. We would use the embedding similarity to be like, all right, this might be the answer we have, and then the traversal was what, like that text, we concatenated it all together with the arrows and stuff and put it in the input prompt.
Okay.
And then be like, these are the 4 best matches we found. Here's also like a description of where they like live in our kind of galaxy of context.
Okay.
As a weird string.
Okay.
So the way I conceptualized that was that you effectively created a system prompt that included the ontology, and that's what you used.
Yeah, the specific kind of component of the ontology. But yeah.
So when you build a whole taxonomy, do you need some specific kind of data, or you just need to put a prompt to the LLM to build it?
To build a taxonomy, I had to curate a data set that was like, there was a bunch of pre-processing and making sure that we were building the taxonomy with a good example set that was representative of what we wanted that first taxonomy to cover. So there was a lot of iteration in like selecting the data set and then making it good to work with.
I've been thinking a lot about workflows for processing unstructured text data where like you get a new piece of text in and you ask a bunch of questions about it, kind of run through. Is this a variation of this, or does the relationship stuff mean it's not really about new data in isolation that you're tagging in various ways?
Repeat your question.
Okay, so there's a lot of workflows that are basically processing unstructured text data where you have a document and you're asking a bunch of questions about it. And some of these things, like the topic stuff, definitely fits into that.
Yeah.
But some of it seems like it's relationships. So do you think is this a variation of that workflow, or is this something else?
This does feel like a variation on that workflow. I've never really thought of it that way. But rather than perhaps, I wonder if in those kind of workflows, is it possible to like run evals against what's being extracted, and then have some confidence as you're updating your like.
Yeah, you do evals. What distinguishes it? What I think of it is you have a document in kind of in isolation where you have a model and you're asking, and so like the topic stuff fits that. But it's I guess how much do you feel like a new document comes in, you look at it in isolation versus it's kind of only has meaning in a context of other documents?
Yeah. I think one way that this might be different is that anytime a new send, so new document went through the system, we, especially if it was a document where we're like, this is a new branch of the tree, so like, or very few objects are in there, so maybe it's a weird branch. We would sample similar sends from that branch and from like the next likely branch and include that. So sometimes like we try to provide more context. We're like, well, if this is what it looks like to be this topic, does this still make sense? But yeah, that was the only other kind of like bigger picture context. Oh, that, and then I guess when we were doing the class, like when we were doing the classifying, even with an LLM, like the entire taxonomy was included. So yeah.
Okay. So then does it change? So when you ask something, does your model change next time for the next documents?
No.
Okay.
Okay, so maybe that workflow. Okay.
Yeah, you. Sorry, you mentioned that KPI is important. So for the customer support use case, what are the KPI used and what's the outcome?
The amount of time it would take on average for a customer support agent to close out a ticket.
And
Yeah, but that was a trailing metric. Because like there's plenty of other things that affect, the customer support agents are working really hard. So that was more of a trailing metric. The leading more eval level metric was the amount of connections between tickets and knowledge articles.
And I suppose in this use case, it was measured, and what's the outcome? Is it indeed improved or?
Oh, the support agent time?
Right.
I have no idea, I'm not there anymore. I hope so.
Not very satisfied.
Sorry. I should just say yes. Fix it. Alright. Oh, yes.
Last question, David.
Okay.
I'm wondering how to start a search. Do you always start from the top and then classify what domain and then you traverse? So if a user asks a question, how do you start? Do you always start with the domain and going downward?
Oh. How did like when we were comparing embeddings to try to.
I'm asked a question, right? For like maybe find the information of like maybe about X, right? And then I input it to you, and then do you classify what domain it is, and then start traversing domain from top level to low level?
Are you saying for like a multi-level ontology, how do you start? Like, did you start at the top and then go down, or?
Basically, how to find the answer. If I ask question, right? How actually working behind the scene?
I think I understand your question. So you're saying like, hey, so like a request comes in, and the text description is what we're going to use to identify similar tickets, right? So in addition to the ticket description, there's like a bunch of properties we collect around it. Like this is how new the user is. This is the configuration for the company and things like for the configuration for the audience page or whatever for the organization or for the user. All of that, what feels like relevant metadata, like which we have as properties on the knowledge graph, we would take an embedding of that, and we take an embedding of candidate nodes, and then compare them with similarity. So we wouldn't traverse necessarily from the top down. Yeah. And now I'm mixing up the taxonomy and the ontology, but yeah. Does that answer your question? Okay. All right. That was the last question.
Okay, prisoners are going to have questions, but I think we have to vacate this space. So if you want to head to Tonic, a couple blocks away, people will probably head there. Hey, how are you? How's everything? Well, doing well.